All right. So at this point, we have talked about, in this unit so far, we've talked about sets, and then we've talked about functions. And the reason we started with sets is because functions are just mappings between sets, right? So it's helpful to know a little bit about sets before you know about functions. The last big sort of topic, and what we're going to talk about over the course of the next 4 lectures, has to do, or 3 lectures, has to do with, the next 3 lectures, sorry, has to do with personal finance, right? And so what we're going to do is we're going to talk about functions and how they apply to your finances. Okay, so we're going to talk about interest, we're going to talk about annuities, we're going to talk about loan amortizations, and all kinds of good stuff. Okay, so in this lecture, we'll review some of the basics regarding simple and compound interest, and so there might not be a lot of new information here, especially if you did, like algebra in high school and stuff. And if that stuff is still relatively fresh in your brain, then there may not be a whole lot here for you to learn that's like brand new. But then we're going to build upon that when we talk about things like annuities in the next lecture. Okay, so simple interest. The simple interest earned or owed on a principal of P dollars invested or borrowed at an annual interest rate R for a time of T years is I equals P times R times T. So it's the interest that you make is the amount of money that you deposit times the interest rate times the time. Okay? Now, note that that's just the interest. If you want to know the total sum of money that's accumulated in your account, well, then it's going to be the original amount that you invested plus the interest that you made on it, right? So it's going to be the principal plus the interest. Well, the interest, remember, is just principal times rate times time. So the total sum is P plus PRT. And then you can factor out the P, and you get P times, that should be a 1, not an I. So it's going to be P times 1 plus RT, okay? So that's the total sum that you make. So other words to describe the principal, the sum, and the time are present value for principal, future value for sum, and term for time, right? So we'll use those terms interchangeably, like principal and present value mean the same thing, and we use the letter P to represent that. Sum and future value mean the same thing, and we'll use the letter S to represent that. And then time and term mean the same thing. We'll use the letter T to represent that. So let's take a look at an example. So this one says Thomas borrows $3,800 at 5% interest rate under a simple interest scheme. Find the simple interest and future value of the loan after 3 years, 9 months, 140 days. Okay. So find the simple interest. So the simple interest I is P times R times T. P is the amount borrowed, so that would be 3,800. The interest rate R is 5%, but you have to change that into a decimal, so don't write 5, right? 5%, you take the decimal, you move it over twice, you get 0.05, right? So this is going to be 0.05. And then time, T is in years, right? I don't know why I capitalized the I there. But anyway, T is in years. So for the time in part A, it would be 3 years. So we would say times 3. So you punch that into your calculator. 3,800 times 0.05 times 3 is 570. That's the amount of interest that he's going to accrue over the course of 3 years, which is not bad. The future value, so we were asked to find the simple interest, that's this, and then the future value. So this is the simple interest. The future value, S, is the principal plus the interest that you made. Okay, so that's going to be 3,800 plus 570. Which comes out to $4,370, right? I guess this would also be dollars. But that's pretty good. Okay, you're not going to find a 5% interest rate, at least not at a bank. You might do that like on the stock market or something, if you invest in GameStop stock or something like that. Anyway, 9 months. So again, simple interest is principal times rate times time. That's 3,800 times 0.05 times time. Now be careful. You're not going to put in 9. It wouldn't make sense. Notice that if you plug in 9 here, this number is going to be bigger than this number was when you plugged in 3. And that wouldn't make any sense, because why would it make sense that you would make more interest in 9 months than you would in 3 years? So you're not going to put in 9. Remember that t has to be in years. 9 months is 9 months out of 12 months. Right? So that's 3/4 of a year. Or if you prefer, you can call it 0.75. So you're really going to say 9 months is 0.75 years. Right? Okay. So you're going to put in 0.75. We get 3,800 times 0.05 times 0.75. That's 142.5. So I guess that would be $142.50 is the interest that you make. The future value then, P plus I, is going to be 3,800 plus 142.50. And that's going to come out to 3,800 plus 142.5. That's going to be $3,942.50. Okay, 140 days. Well, looking ahead, I know that I'm going to have to get this in terms of years. So it's 140 days out of how many days? In 1 year, there are 365 days. So 140 out of 365, that's 28 out of 73. But it's approximately, I'm going to say this is approximately 0.38. So this is the number I get. It was pretty nasty, but I'm going to cut it off maybe at the third decimal place and call it 0.38. If I want to round to this one, then I move up to the next one, and it's a 5, so I'm going to round that up to 4. So 0.384. Okay. So the interest, the simple interest, principal times rate times time, 3,800 times 0.05 times 0.384. Is 72.96. Okay, and to see if that jives with our sense of logic and order, we know that a month has about 30 days in it, so 9 months would have about 270 days. So this is a longer period of time than that. So it makes sense that the interest accrued is more than that. Okay, so I'm comfortable with that. Okay. What about the future value? That's going to be principal plus interest, right? So 3,800 plus 72.96. That comes out to 38.72. Oh, I should have been able to do that in my head. Duh. 38.72.96 is the future value. Okay. Here's another example. It says how much money must be invested now under a simple interest scheme at 6.5% to achieve a future value of $19,200 after 18 months. What if the rate were 7.5%? Okay. Well, the future value, S, we know that that's P plus I. Right, it's P plus I, but we also know another way to say it is that it's P times 1 plus RT. So I'm going to use that other formula this time. P times 1 plus RT. Okay. In this case, I'm given the future value, right? I want the future value to be 19,200. So for S, I'm going to plug in 19,200. P I don't know, because that's what I'm being asked. I'm being asked how much money must be invested. So I don't know P. The interest rate is 6.5%. If I change that into a decimal, that's 0.065. And the time is 18 months. 18 months is 1.5 years. So I'm going to say 1.5 years. Okay, so I get 19,200 equals P times, I'm going to punch this stuff into my calculator. 1 plus 0.065 times 1.5 is 1.0975. Let me let my dogs out. Okay. So we get to this point. Now, if I want to solve for P, this is P times this number. So if I want to solve for P, I can divide by that number, right? So I can divide by 1.0975 on both sides. 1.0975. And so I get P equals that. I'm just going to punch that into my calculator. 19,200 divided by 1.0975 is $17,494 and it looks like 31 cents if I round to the nearest penny. So that's how much money I have to invest in order for this sum to grow to that sum within an 18-month period of time. Okay? That's if the interest rate is 6.5%. If the interest rate is 7.5%, well, then I'm going to go through a similar line of reasoning, right? I'm going to say 19,200 equals P times 1 plus 0.075, right? 7.5%. Times 1.5. So 19,200 equals P times, now this would be 1 plus 0.075 times 1.5. That's 1.1125. To finish solving for P, then I divide by 1.1125. And so I get P equals 19,200 divided by 1.1125. And that's 17,258.4. Right? And again, it's good to make sure that this jives with like our sense of logic and order, right? Because if the interest rate is larger, then I can afford to put less money into the account, right? So notice that this is less than that, because here my interest rate was 7.5% and here it was only 6.5%, right? And in both cases, I'm trying to get up to $19,200 in 18 months. So it makes sense that if my interest rate is larger, my principal can be smaller. Okay? One more example, and then we'll move on to the next topic. It says the monthly fee that most credit card companies charge for their services is computed as simple interest on the average daily balance for the previous month. Isabella's balance on her fast credit card from last month is $200. In the current 30-day period, she charged a $27 dinner on the 10th day, a $43 pair of socks on the 16th day, and $86 worth of groceries on the 21st day. If the annual interest rate is 9%, what is her finance charge for the month? Okay. So this is kind of tricky, but we'll assume that this month is 30 days long, right? Because we're told that it's a 30-day period. And we're told that she has a balance from the previous month, and that balance is $200. So the fee that they charge is going to be the annual interest rate. The annual interest rate times 30 out of 365 times her average daily balance. Well, what's her average daily balance? Well, since she had a balance of $200 coming into the month, her daily balance on day 1 was $200, and her daily balance on day 2 was $200, and her daily balance on day 3 was $200, and so forth, until she gets to day 10. When she gets to day 10, she charges a $27 dinner to her card. So her balance was already $200. On day 10, it's going to be $200 plus 27, so $227. And then her balance is going to be $227 on day 10, day 11, day 12, day 13, day 14, day 15. On day 16, it's going to be $227 plus 43 because she makes another charge on day 16, right? And so on for the whole month. So if I wanted to find her average daily balance, well, I would add up each individual daily balance and then divide by the number of days, which in this case is 30. So here's what it would look like. It would look like 200 plus 200 plus 200 a bunch of times. Okay, 10 times. Actually, not 10 times, right? Because on the 10th day, she makes a charge. So this would happen 9 times, right? The first 9 days of the month. And then on the 10th day, she charges a $27 dinner, so it's going to be $227 plus $227 a bunch of times. How many times? On days 10, 11, 12, 13, 14, and 15. So for 6 days. So 6 times. Then she charges $43, so it's going to be $227 plus 43. That's $270. How many days is her balance equal to 270? Well, she makes this charge on day 16, so it would be day, and then on day 21 it's going to change again. But on day 16 it's going to be 16, 17, 18, 19, 20. So 5 days. So 5 times. And then finally on day 21, she makes another $86 charge. So it's going to be $270 plus 86. So that's $356. So for how long? That happens on day 21. So day 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So for 10 days, right? So 10 times. Okay, and that accounts for all 30 days, and then we would divide that by 30 days, right? This is her average daily balance, right? This is her average daily balance. There's a shorter way to write this, of course, right? You could call this, instead of saying 200 plus 200 9 times, you could just say 9 times 200, right? So 9 times 200 plus 6 times 227 plus 5 times 270 plus 10 times 356 divided by 30. And that comes out to, so make sure to put parentheses around the numerator, right? But you're going to have 9 times 200 plus 6 times 227 plus 5 times 270 plus 10 times 356 divided by 30. So to the nearest penny, that's $269.07. So $269.07. That's her average daily balance. We're going to multiply that by the interest rate and then times the 30-day period. So the monthly fee, so the interest that they charge, is going to be 269.07 times the interest rate of 9% annually, which is 0.09 as a decimal, times the amount of time. So it's a 30-day period. That's 30 days out of 365 days in a year. So I'm going to punch all that into my calculator. 269.07 times 0.09 times 30 out of 365 is about $1.99. Comes out to $1.99. Wouldn't you know it? Anyway, so that's the service charge. So of course, her balance at the end of this next month is going to be 356 plus 199. So it's going to be, 357 and 99 cents. Okay, that's that. Okay. So that's simple interest. Now, we discussed back in lecture 15, kind of briefly, that compound interest is far more common in the real world than simple interest is. The idea behind compound interest is that the interest isn't only accrued once during the term of the loan. Instead, interest is accrued at the end of an interval of time called the interest period. That interest is added to the present value, which then goes on to accrue more interest during the next interest period. So basically, in addition to the principal amount, so the initial amount of money you invested, in addition to that earning interest, the interest also earns interest. Okay, so for instance, let's say that A of t is the future value of P after t years of annual compounding. Right? After 1 year, the amount of interest is computed and added to P. So after 1 year, the amount is P plus interest rate times P. Or we can factor out the P and call it P times 1 plus R. Okay? That's because T equals 1 in this case, right? Anyway, now A of 1 is the amount in the account at the beginning of the second year. So at the end of the second year, we have A of 2 equals A of 1 times 1 plus R. Okay? That's A of 1 was P times 1 plus R. So it's P times 1 plus R times 1 plus R. That's P times 1 plus R squared. Similarly, after 3 years, A of 3 is going to be A of 2 times 1 plus R. That's P times 1 plus R squared times 1 plus R, which is P times 1 plus R cubed. Notice that after 1 year, it's P times 1 plus R to the first. After 2 years, it's P times 1 plus R to the second. After 3 years, it's P times 1 plus R to the third. So in general, after t years, we have P times 1 plus R to the t. That's the amount in the account. Now, if the interest period is more than 1 year, more than once per year is what I think I meant to say. More than once... more than once per year, then we need to divide the annual interest rate R by the number of times each year that the interest is accrued. Okay, we would also need to compound the interest that many more times. So, putting it all together, we get the following fact. If P is invested or borrowed at an annual interest rate R, compounded M times per year, then the amount, A of t, in the account after t years is P times 1 plus R over M to the MT. Sorry, this is the formula. P times 1 plus R over M to the MT. So let's walk through some examples here. So example 4 says, determine the future value of $1,000 in a savings account that compounds annually at a rate of 8% after 5 years. Compare this to the amount acquired if only simple interest is computed. Okay. So since the amount is compounded annually, this means that M equals 1, right? It's only compounded once per year, so M equals 1. So we would say we want to know how much is in the account after 5 years. So we would say A of 5 equals principal amount, that's $1,000, times 1 plus R, interest rate was 8%, so that's 0.08, divided by M, which we just said was 1, to the M times T, which we're saying is 5. Okay, so we can plug all that into our calculator. Just to make it a little easier, we can call this 1,000 times 0.08 divided by 1 is just 0.08, and 1 plus 0.08 is 1.08. 1 times 5 is 5. So that's what I'm going to punch into my calculator. 1,000 times 1.08 to the 5th. That comes out to about $1,469.33. Okay. Now it says compare this to the amount acquired if only simple interest is computed. So if simple interest is used instead of compound interest, in other words, if we don't compound the interest at the end of each year, if we just compound it after the end of the 5-year period, how much money would be in the account? Well, the sum would be P times 1 plus RT. So that would be 1,000 times 1 plus 0.08 times 5. So punching that into my calculator, 1,000 times 1 plus 0.08 times 5 is $1,400. So this is with simple interest. Compound interest. This is if it's compounded annually. Okay, if it's compounded annually. So you can see we like compound interest, and most interest in the real world is compounded. It's actually compounded monthly for the most part. So like your bank account interest, for example, is compounded monthly. Okay. Here's another set of examples. It says a bank offers a 6 1/8% interest rate with monthly compounding. This is kind of annoying, but your book does this sometimes, so I wanted to give you an example. But you can just change 1/8 into a decimal. So this is 6.125%. Okay. Interest rate with monthly compounding. So if it's compounded monthly, then that means M equals 12. If it's compounded monthly, then it's compounded 12 times per year. So M equals 12. All right, find the future value of $2,500 after 3 years. So we're going to say A of 3, right? The amount in the account after 3 years is the principal amount times 1 plus interest rate. If I change that into a decimal, it's going to be 0.06125 divided by number of compounding terms, 12, to the 12 times 3. You could punch that all into your calculator at once. Let me show you how I would type that in. I would say 2,500 times, open parentheses, 1 plus 0.06125 divided by 12, close the parentheses, to the power of, and in my calculator that means that I have to use this little caret this little caret key. So to the power of, and then I'm going to open parentheses and I'm going to say 12 times 3 and close parentheses, right? Then my calculator is really nice and it'll display it so that I know that I put it in correctly. But that's about $3,002.88. 88 cents, right? So this time when we round, we're rounding to the nearest penny. The next number is a 4, so I don't round up. I just keep that 88. So $3,002.88. Okay. Part B. Find the future value of $2,500 after 5 years, 6 months. 5 years, 6 months. That would be 5.5 years, right? Okay. So we're going to look at A of 5.5. So everything else is the same though, right? And in fact, in my calculator, I'm just going to go back and change this number. That's the only number that changed. You can change it to 5.5. $3,498.41. Part C kind of switches it up a little. It says, if you wish to accrue $7,000 in 4 years, so it's giving us the future value and the amount of time that we want to accrue it. Then it asks, how much money must you deposit now? So it's asking, what's the principal going to have to be? So, well, the amount, 7,000, equals the principal times 1 plus 0.06125 interest rate, right, divided by M, 12, to the M, 12, times T, 4. So we can solve for P. Right, we're going to get 7,000 equals P times, and I'm going to punch this stuff into my calculator and see what I get. So it's 1 plus 0.06125 to the power of 12 times 4. So that's, well, we can call it 17.34801. I want to round to the nearest penny, so I'm just going to take as many decimal places, that many decimal places, because I think that'll get me to the nearest penny. But if I want to solve for P now, I need to divide by 17.34801. So 7,000 divided by 17.34801. Hold on a second. I made a mistake. This isn't right. It's because here I forgot to divide by 12. There we go. That makes a little bit more sense. So this should have been 1.276825. Anyway, I wrote it down correctly. I just punched it in wrong. So this will make more sense, hopefully, when we get to the end of it. So we're going to say 7,000 divided by that number, which comes out to about, yeah, this makes more sense, $5,482.35, approximately. Okay. Okay, another example. Okay, so one more example and then we'll look at a different concept and we're almost done. Okay, so it says you deposit $830 in a savings account at a bank offering an annual interest rate of 5.25%. What amount of money will have accumulated in that account in 6 years if the compounding is done annually, quarterly, monthly, and daily? So let's see. If it's compounded annually, then the amount in the account after 6 years is the principal, 830, times 1 plus the interest rate, 0.0525, divided by the number of times the interest is compounded. If it's compounded annually, then that number is 1 to the 1 times t, which is 6. So I'm going to punch that into my calculator, 830 times 1 plus 0.0525 divided by 1 to the power of 1 times 6. Okay, and so that comes out to about $1,128.26. If it's compounded quarterly, that means 4 times a year, right? Then A of 6 is going to be 830 times 1 plus 0.0525 divided by 4 to the 4 times 6. And so I'm just going to come back here and replace my 1s with 4s. That comes out to about $1,134.99. Okay, what if it's compounded monthly? If it's compounded monthly, then that means it's compounded 12 times per year. So the amount in 6 years would be 830 times 1 plus 0.0525 divided by 12 to the 12 times 6. So I'm going to come back and change my 4s to 12s. And we get about $1,136.53. What if it's compounded daily? Then A of 6 is going to be 830 times 1 plus 0.0525. If it's compounded daily, that means 365 times a year. And let's see what we get. So I'm going to come back here and change my 12s to 365s. And that comes out to $1,137.29. Okay, so as you can see, as the number of times that we compound per year increases, the amount in the account will increase. But the amount of increase, but it's not increasing as much down here as it did up here, right? So it does reach a limit where you're just, no matter how many more times you compound in a year, you're just not going to be adding that much more to the final amount. But anyway, that's another topic for another time. The main thing is that it should now be clear that even if the interest rate is the same as it was in the previous example, the amount of money earned will increase as the number of interest periods increases. And that's what that previous example showed us. So you may wonder exactly how much interest you will earn in a year if the interest is compounded more than once that year. Okay? This is called the effective rate or yield. Okay? So in other words, the effective rate or the effective yield is what percentage of interest you're going to earn if the interest is compounded more than once per year. So if you have like a 5% annual interest rate, but you compound monthly, then you're going to make more than 5% on your money that year. And so what percentage interest are you actually going to make? That's called the effective rate. And the effective rate of an annual interest rate, R compounded m times per year, is 1 plus R over m to the m minus 1. And this is already a long lecture, so I'm not going to talk about where that formula comes from, but you're welcome to look it up in your book. The book does have a derivation of that formula. But what I want to do is show you an example. So it says, compute the annual yield for the following annual interest rates if the interest is compounded daily. Okay, so here we're given our annual interest rates, but the interest is not going to just be compounded once per year. It's going to be compounded daily, so 365 times a year. So the annual yield is going to be a percentage, and that percentage is going to be 1 plus R over m to the m minus 1. So that's going to be 1 plus interest rate, 0.0825 divided by m. If it's compounded daily, then m is 365 to the 365 minus 1. Okay, so let's see. If we plug that into our calculator, we're going to get 1 plus 0.0825 divided by 365 to the power of 365 minus 1. And you should come up with 0.08 we'll say 60, right? So this is kind of a strange case, but it's like the 9. If I wanted to round to this decimal place, the 9 has nowhere to go. It has to go up to, the 59 has to go up to a 60, right? So that's what I've done. Whoops. Anyway, so you change that into a decimal, which means move the decimal place over the other way. You get 8.60%. So that's the annual yield. Okay? So if the annual interest rate is 8.25%, but you are compounding daily, then the actual amount of interest you're going to end up making at the end of the year is 8.6% of whatever your principal amount was. Okay, so that's the annual yield. Let's do the same thing for the 9%. So the annual yield is going to be 1 plus R over m to the m minus 1. So in my calculator, I'm just going to go back and sorry, this should be the interest rate this time is 9%. So that's the thing that changes. So I'm just going to go back and change in my calculator the 0.825 to 0.09. Okay, and so I come up with 0.0942 approximately. I should be saying this is approximate, right? But that's 9.42%. Okay, so again, if the annual interest rate is 9%, but your interest is compounded daily, then actually at the end of the year you're going to make 9.42% of the principal amount in interest. Okay. Last one, for the 10%, we're going to have 1 plus 0.10% divided by 365 to the 365 minus 1. Let's see about how much that is. So 1 plus 0.1 divided by 365 to the 365 minus 1 is about 0.1052 or so, and that's 10.52%. Okay, so that's how annual yield or effective yield or effective rate, right? That's how that works. So that's that. That's all I wanted to say about simple and compound interest.